Hello everybody, how's it going today? My name is Connor, welcome back to another video. Today I'm back with the game engine, with Weaver, my game engine. And man, it has been a while, hasn't it? so basically, since I've last uploaded a video about this game engine, the entire thing has been scrapped and rewritten. Um, I've been kind of hyper focusing on this rewrite, which is why I haven't uploaded. So sorry for that. Um, but yeah, the entire thing's been rewritten, and as you can see, it looks very different now from when the last time you saw it. So what's going on here? So first of all, there's been some changes in philosophy from the old kind of way I was doing the game engine. So originally, I wanted to have a software renderer that was writing from scratch that actually ended up looking pretty darn good. Let's see if I can find some screenshots of that. Yeah, so this was just, yeah, this is probably the last thing you guys saw, right? Was just a rotating cube. So I eventually got, filled triangles working, and I got simple Phong shading working, and um, I got all kinds of stuff going. Um, Second of all, yeah, so I also got like where is this? Yeah, so that's just like a screenshot of um, the Phong shader with multiple objects, and I got a little input thing going. So this is just kind of where it's been for the last month or so, month or two actually. So eventually got it rendering stuff like that, and where's this? Yeah, so I got it to do texture sampling, just nearest neighbor texture sampling, nothing too fancy. Um, this is all in the software renderer. Um, And let's see, what's this? Yeah, I got like color lights working, um, like spotlights, and being able to make them bigger and blah blah blah. It's kind of a pseudo deferred rendering thing, which I'll actually get into soon because I'm still using that kind of architecture for the current renderer. So anyway, software renderer, blah blah blah. It just sucked. I figured I'd save myself the headache of having to optimize something like that, you know. Um, so what has changed is the render is obviously, as you can probably tell by the speed at which this is running, it's on the GPU now. I'm using WGPU create. Um, so uh, yeah, WGPU create in Rust with WebGPU API to render all of this stuff that you're seeing here um, out in the game world. Let's go ahead and do a little demonstration. What do we have here? So as you can see, I have some textured meshes. I have a little frame rate display up in the corner, and this is kind of my latest like demo for the project. I can kind of pick objects in the world. I can grab them and move them around. I can rotate them. This is kind of similar to Blender, kind of similar uh, controls to Blender. I can scale, rotate, move objects around. I can even spawn in crates now. That's a recent thing. So move those around. The idea is to eventually turn this into some kind of editor for a actual game engine, so I can add like logic and maps, and make maps and make entities and spawn things into the world and do all the logic and stuff eventually. So that'd be pretty cool, I think. Nothing really moves around on its own right now just because I don't have a system set up to move anything around on its own. But I could totally do that if I wanted to. So just kind of testing my screen picking compute shader. Anyway, so that's all that. Um, so let's go into the code. Go get rid of that. And let's see what exactly has changed with the code. So uh, first of all, I have overhauled the renderer, of course, with WGPU, like I already mentioned. I've also overhauled the anti-component system, the ECS. Um, so what's going on there is I've actually, sorry, I'll stop scrolling around. I've actually started using procedural macros to do things like custom derives and custom attributes. And I'll show you an example of what the actual main.rs looks like right now. So you can see here, I'm deriving a resource. This is it's a custom resource derived macro to derive resource from this editor state, and it just has a bunch of parameters for the quote-unquote editor, like just be able to move stuff around. Driving component from objects, or driving component from this object struct. And then I have a bunch of materials I can load now. So here's what an actual system would actually look like, right? So I have this hashtag system, and I give the system a name. This is actually the name of a struct that you can then add into the main entity compose system world. So it's just a unit struct, zero size struct that doesn't really have anything associated with it, which is kind of cool. It means the systems are entirely implemented via a trait and through procedural macros. So I'll get into the details of that in a bit. So and then I have another one for Egui update, and you can see that it looks very similar to Bevy. If you're familiar with how Bevy works, which is another game engine that was written in Rust, I took a lot of inspiration from Bevy for how this whole thing looks and feels, because I really like how Bevy looks and feels. So it's a very data-driven, data-oriented architecture for this game engine. So you see I have things like res mute for mutable handles to resources, res for immutable handles to resources. I have queries that can have mutable references to objects, or to components, or immutable references to components. Let's see. Yeah, so you can have compound queries that query for entities that have all of the components. You can even do I don't think I have any here, but if we go to my tests in the ECS module, you can see that I'm testing all the different kinds of queries here. I can even do, where is it? Yeah, option. I can put an option in there to have it, put, do like an optional value, an optional type of component in the query. And I can match over the option just like a regular option. And then I even have these filters. So notice how this one says query position and then comma with velocity. So what this will do is when you iterate over the query, or when you get the results of the query from an entity, then you only get what's on the left side here. And then with the filters, these just add extra filters onto what you get out of the left side, right? What entities are included when you iterate through the query. So hopefully that makes sense. You can also do it without query. So, like for example, let me give you an example. Like this query for position with velocity will, when you iterate through it, it will return references to all of the position components. All the position components belonging to entities that also have velocity. And with the without query filter, you'll be iterating through all the entities that have position and don't have a velocity component. That makes sense? So it's kind of black magic, honestly. It's this is just a today thing that I just got working today, and it's what actually inspired me to make this video, is talking about the queries and how they work with the ECS. So I can go into how all that works in a future video into detail. I'm just kind of covering what's new here, you know. So yeah. Let's see. Overhaul the renderer, overhaul the ECS, and I also add the Egui integration. That's just kind of a minor thing. I just kind of added into this script, I guess. So, but I guess it's there. It kind of works together with the renderer. It uses the renderer's frame buffer to render the Egui. UI to the window, so it's all integrated with all that. That's super special. But anyway, and this Egui context is actually a resource, so you can actually I have this function called draw if ready, which is basically it allows you to actually render things to the GUI and by using the GUI context as a resource. So you can use it as like a res or a res mute in any system, and it's very similar to how it worked in Bevy. So yeah, that's gonna be a theme here. I'm kind of replicating Bevy how they do a lot of things with this engine, and I honestly haven't looked too much at the Bevy source code. I should also mention I'm kind of just like taking the ideas and kind of implementing them in my own way from scratch. So I've only looked at the Bevy source code in like very sparingly, like super desperate, I don't know how to do this kind of situations. So like the query filters, like I was trying to figure out how to make them work, and I realized that Bevy actually uses them as like a separate type parameter. So anyway, besides the point. So let's talk about the renderer. Um, we have here the main renderer struct, and it's kind of like I mentioned before, it's kind of going into like a pseudo kind of deferred structure. So we have the concept of a render pass, and we also have compute passes, or just compute, um, compute modules, I guess. I'm using that for picking from the screen right now, like projecting an array from the screen position to a world position, and then seeing what the position and normal of that is, right? Um, so right now I have this concept of a render pass. The currently built-in passes are I have a PBR pass, which is to render the meshes and materials themselves. I have a a shadow pass. This handles the dynamic shadows. Right now it's kind of broken for for directional lights. I'll kind of scroll through this a little slowly. Yeah, so shadow render pass. It works in 4 stages. First stage it creates a shadow map. Second stage creates a shadow cube map for all the all the point lights. And the third and fourth stage overlay each of those on the scene. So this is actually kind of more of a true deferred rendering kind of thing, where I'm actually taking as input to the shader a texture. I can actually show you that. Taking as input to the shader the color in texture, and I'm just sampling from that in order to get the final output. In the shader, in the fragment shader. So let's see here. Yeah, so shadow pass, really, really big structure. It's like, how many bytes is this? Yeah, 2x500 bytes to 1280 bytes. So anyway, it's really heavy, but it gets the job done, I guess. So, I have the PBR pass, the shadow pass. I have HDR decoding pass. So right now the renderer actually renders the entire scene in high definition range space in HDR space, color space. But the window render target actually works in sRGB linear color space. So I have a HDR decoding pass, which is just a simple vertex and fragment shader that that maps the HDR space into the ACES tone map, which is something I found on the internet, honestly, to get it from HDR color space into sRGB linear space. So it's that. I have that. I have the skybox pass. So if you saw like back in the demo, we did have a skybox. So the skybox actually has a HDR texture that is used. Sorry, an HDR texture that is used as loaded by an HDR loader, which also uses a compute shader to map the HDR texture into a cube map. So, and then finally, I have the doodad pass. This was fun because it's just rendering random shapes to the screen. It's the thing that was like, here's the actual doodads module in the actual game engine library. You can see that I just have like I can render a cube or a cone on the screen at random positions or whatever positions. Like if you look here, like this right here is a doodad that I'm rendering, and this cube right here is a doodad. So I can change its color, I can render it wherever, and it ignores the depth buffer for everything else, so I can always see them. It's kind of like an overlay thing, but that's why it's its own render pass. Hey, users. Yeah. So that's pretty much it for the renderer. Other than that, typical WGPU stuff. I can go into more detail in a future video. If you want to see me talk more about the renderer in more depth, let me know. Next, I want to talk about the engine component system. So, I'm going to give you a little peek at this procedural macro library that I've created. It's very long, it's very complex. But essentially, I'm able to derive component and derive resource from structs, which is very, useful because then I don't have to implement the trait myself. It's not like other ECS libraries where it's like I have to specify the storage type and I have to specify the archetype and I have to specify the blah 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 blah, all this, super involved crap that makes it super a pain to work with, in my opinion. So yeah. So most important thing is to note is that if we go into the component trait, is that every component has a component ID, and this is actually a static number that is baked into the binary by the procedural macro, by the derived macro. So that's why it's marked as an unsafe trait, because you're not supposed to implement this manually. So yeah. So, and how I actually end up doing that is in the procedural macro, I have a static atomic number, a static atomic integer that is incremented every single time the derived macro for component or resource is run. So what that ends up doing is at compile time, it counts up all of the derived component, derived resource instances, and just gives them all a different number at compile time. So I found that to be very kind of hacky, but it works. It works. So and then I have some. Let's see. Yeah, here's the system implementation macro, and you can see that I've written some notes here um, on what valid queries are and what valid resources usages are. I used to be able to statically kind of type check the queries and everything to make sure nothing was queried twice, but that got really complicated once I added the whole filtering system. So I'm leaving that out for now. But kind of scrolling through this a little bit. If you really want to check out the source code, I can leave the link in the description to the GitHub repo. Nothing to really explain here. It's just a bunch of procedural macro magic. Let's see. There's some helper macros to implement bundle for certain things and helper macros to implement queryable for certain things. Let's actually talk about the queries, actually. This is what I want to talk about next is how the queries work. So, first things first, it's actually kind of the main thing that motivated me to make this video, so I'm going to talk about this for at least a little bit. So first things first is every component in the world, actually let's go over here. Every component in the world is stored in a hash map inside a hash map, and each inner hash map contains a reference counter pointer and a ref cell. Now this is a really kind of standard way to do something called interior immutability in Rust. Is to have a reference counter pointer and then a ref cell or a mutex or a rewrite lock or whatever. And it's kind of interesting because internally in the world they're stored as ref cell of dynamic component. So it's actually a trait object and not the concrete type of the actual component itself. Now I have to do that in order to be able to keep them all inside the same structure. But then you may ask how you actually get them out of that dynamic component form. I had no idea I could do this until I started working on this project, but you can actually, it's really magical. Here it is. Ref map, ref : map, or ref mute : map. What this will do is, so what happens is when you borrow from a ref cell, you get an object called a ref, right? And what the ref is let's see, it has a lifetime associated with it. So, and when the lifetime of the ref ends, aka when the ref goes out of scope, the borrow, quote unquote, the interimmutability borrow on the object that the ref is referring to is released, and you won't get a runtime error if you try to borrow it again, right? So, all that being said, so the ref has an integer type, right, where it holds on to this value, this pointer to this value, with a certain lifetime. You can actually map that integer value into something else that has the same lifetime. As long as it has the same lifetime, you can actually like kind of transmute that internal value into something else. As long as it, like I said, as long as it matches the same lifetime. So I'm taking advantage of the any trait in the Rust standard library. I have this trait called downcast, and component is a subtrait of downcast. So anything that implements component has to implement downcast. So, and downcast is implemented for anything that implements standard any, right? So this any thing it's kind of like it says in the documentation, it emulates dynamic typing. Anything that is, have a static lifetime implements any. So that being said, anything that is an any has a trait called downcast, or has a method called downcast ref that allows you to, if you're downcasting it to the same type that it actually is, then it will return some of the actual thing. If not, it will return none. It returns an option, right? So come on, there we go. So yeah, downcast ref returns a reference to inner value if it is of type T or none if it isn't. So you also do as any dot is, and that will return a boolean if it actually is that thing. So you can use that to kind of pre-check if that thing is that type. It's all very confusing, right? So, but it promise to make sense to me at least, mostly. Anyway, it's just a very elegant solution, I think, for getting something like this to work. It's actually what Bevy does as well. So this is something where I looked at Bevy's source code. I was like, okay, they're doing it with std any. So that's why I'm going to do it. But yeah, anyway, you have optional stuff, and you can have the with and the without, and you can have all that stuff. Anyway, I'm getting sick of talking, so I'm going to move on to the next topic, and that is what I want to do next. And pretty much what I want to do next is just optimize, basically. This, you can see, I'll run another demo once again. It's running around 200 frames per second, 240 frames per second. That's even while I'm recording. But, as you can see, when a computer shader runs to pick in the world, it drops by about 20 frames per second. That's obviously something I'd like to fix. And if I add lots of objects into the world, then you see the frame rate starts to really tank. So, yeah, now we're down to only 100 frames per second after adding only like 20 more objects. So, yeah, that's no good. So I just want to optimize my code, and I'd like to add other things, other cool, bells and whistles like physics, or like an actual, working towards an actual editor or something like that. But for now, I think my main focus is going to be optimization. So, yeah, that about does it. I know this was a longer video, kind of. It's pretty normal by my standards, but I just wanted to cover everything that had happened with this project and everything that had been going on with it. Thank you all very much for watching. If you want to check out the code, I'll leave a link in the description. If you want to check out anything I talked about in this video, I'll try to leave some references to people who are trying to figure out the same things I was trying to figure out for the past month. So, anyway, thank you all very much for watching. If you like this video, leave a like. If you want to have a comment for this video, you can leave a comment. If you want to see more of my rantings and ramblings on my projects that are random like this, then you can subscribe. I would really appreciate it. It really helps me out. So thank you all very much for watching. I'll see you next time. Peace.